Okay, well, I hope that a lot of your days get better as it goes on. I mean, I always try to be optimistic, or at least I try to be. Um, Big picture, remember tomorrow you've got your angles and their measures assignment due. Hopefully that shouldn't be too challenging if you're not already done with it, or if you need some help, come on in, let me help you with that. Tomorrow we also have what quiz? Inverse functions quiz, so I'm not too concerned with that. I'm hoping it'll be just as good as the composition quiz was. But big picture, a week from Monday on the 14th, you're going to have your first exam of the grading period. I'm catching myself now. I'm not saying 6 weeks because it's only got 5 weeks in it. But I've also got another quiz scheduled for next Wednesday, the 9th. It's our first CFA of the grading period. What does that mean, CFA quiz? Yeah, remember that's the where we take it on Eduphoria through the Chromebooks. It's multiple choice, so that's going to be, probably beneficial. Hopefully that should be a good grade. It will be over this material here, right triangle trig. Okay, so we actually are pretty much finishing up the lesson today. Just a few other things. Waivers, if this applies to anybody. Remember, tomorrow is the deadline. You can go ahead and grab one from Mrs. Edwards in the office, Mr. Young's secretary. I think it's due to him by noon tomorrow. Several people have already approached me about the digital copy of the textbook. If you are one of those people who want it, it's just kind of unusual. Before you go to this website, the connected.mcgrawhill.com, you got to come talk to me. I find your name in the system. I assign you that, and then you can go in and download that copy. So if anybody's interested, please let me know. And you'll notice we have a guest with us today. His name is Mr. Yacht. He's a senior Texas Tech student, so I will turn it over to him and let him say hello. Okay. So we have an opportunity here. We have a college student. Would anybody like to ask a question? Oh, here we go, Jordan.
Okay, why did you want to be a high school teacher out of all the kids that go here? That, like, the crazy, like, nonsense, like, how do I put this very nicely? The ghetto kids.
So you're saying Lubbock High is made of nothing but ghetto kids?
No, we have the ghetto kids, and then we have the upper class.
Okay.
Like us.
Like us? Okay, the distinction thrown in there.
Why be a high school teacher?
There's a lot of different kinds of students.
Yeah.
There's students that are just out of students. Not really. They're just students that aren't fed up with everything that they need to do. My teachers, my coaches in high school did a lot for me. They helped me grow up and become like an adult. So I just want to do that for other people.
Okay. All right, so excellent. Anybody else? All right, so he's going to be with us on Thursdays through Thanksgiving, is that right?
I think
Probably just before Thanksgiving?
yeah.
Okay, so he's probably going to be, as time progresses, working a focus activity with you, maybe even teaching part of a lesson, and just interacting with you guys. So if you have questions, please feel free. All right. I think that's everything I have. Let's go ahead and get started. Good news is some of the lessons today will still be review. A lot of geometry ideas are going to be coming up, but there are some brand new ideas as well. So let's start with something that's familiar. Similar geometric figures. They have the same shape. Specifically, their angle measures are equal, and their sides starts with a P. Proportional. There we go. Proportional. Okay. Well, here are the 6. Oh, something. Hello. Thank you. Okay. Emma. So these are the 6 trig functions that are going to just be involved in everything we do for a very, very long time. Now, the first 3 you're already going to be familiar with because what was the, I guess I'll call it an acronym, for lack of a better word, in geometry? SOHCAHTOA. Okay, say SOHCAHTOA and everybody knows what we're talking about. So I want to go through and define the ratios for each of these, starting with sine. So its abbreviation is SIN. So sine of theta is, what is that? opposite over the hypotenuse. There we go. Okay, so sines ratio is always the opposite over the hypotenuse. In fact, let's go ahead and fill in this triangle to the side. You'll notice this bottom left angle is what we're referring to as theta. So we have the opposite, we have the hypotenuse. What's the other side length? The adjacent. There we go. So if I place theta here, the opposite and adjacent are very specific to that location. So the side across, that would be my opposite. Okay, the hypotenuse is across from the right angle. And of course, the only side length left would have to be my adjacent. Okay, now, depending on the angle you choose, that will change the sides. And I'll go ahead and show you that when we finish up. But let's continue with cosine. It is abbreviated COS. And what's cosine's ratio? Adjacent over the hypotenuse. There we go. And let's finish up with tangent. Okay, and I'm not referring to that guy who spent too much time at the beach. Tangent. Okay, Jordan went right past it. Jordan, what's that ratio? Opposite over adjacent. Perfect. Okay. Now, these new trig functions, they are the reciprocals of the ones you used before. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. How many people already have experience with the new three trig functions? So a decent amount. Okay, good, good, good. But the key word there is reciprocal. Cosecant is going to be abbreviated CSC. So if sine is opposite over hypotenuse, what's cosecant? Hypotenuse over the opposite. And that's what can make evaluating these trig functions pretty easy sometimes. If you already know the reciprocal, well, then you can find a particular one like cosecant. So secant is going to be abbreviated SEC. What would his ratio be? Hypotenuse over adjacent. There we go. And our last one, cotangent, abbreviated COT, and it is the reciprocal of tangent, so adjacent over opposite. Okay. So these are the ratio definitions for my 6 trig functions. And we want to be very familiar with these. Okay, I hate to use the word memorize, but we need to be able to evaluate trig functions very quickly. In a couple of weeks, I'm going to be starting what's called happy minutes. I'm going to be providing you a certain amount of time at the beginning of class where I'm going to give you one or several trig functions that you're going to have to evaluate. Each of these is going to be for a grade. And we're going to be doing this daily. So it's going to be kind of rough in the beginning, okay? But don't worry. That's why we're practicing this. You will get better. Okay, things are going to happen. So, and this is where it all starts right here. The only other thing I want to go ahead and point out, I said at the beginning that these sides were very specific to the angle you were using. So, for example, there's theta, but if I go ahead and say alpha, which is the other angle, well then from his point of view, this is now the opposite. That's now the adjacent. So just something to keep aware of. You know, those sides are going to be very specific to the angle you're referring to. All right, well, let's go ahead and start practicing these. We're going to look at some special right triangles, starting with the 45, 45, 90. Now, in fact, the 45, 45, 90, it is the only isosceles right triangle that we have. What's that mean, isosceles? Okay, at least 2 sides are congruent. There we go. What's the relationship between the sides? Let's do that in terms of x. Okay. Well, we know that this is isosceles, so the 2 legs would have to be x, x. But how do I find the hypotenuse using a leg? X square roots of 2. There we go. The hypotenuse is the square root of 2 times the leg length. All right. Now here, I'm going to go ahead and actually put in some values so that we can work with these. So let's say the leg lengths are 1. So that means the hypotenuse would be the square root of 2. All right. Now in the beginning, especially if you're having a little bit of trouble with this, the angle you're referring to, I notice that some people like to go ahead and label the sides. So from this 45's perspective, this is the opposite. this would be the adjacent, and this would be the hypotenuse. Okay. If labeling those sides is something that helps you out, fantastic. If you don't need to do it, then don't worry about it. Okay. So let's start with the sine of 45 degrees. Okay. So I need the opposite over the hypotenuse. Okay. Adrian, can you start me off here? What's the sine of 45 degrees? Okay. What's the opposite length? Sir? Well, now, we're looking at angle 45, so now our answer is going to be in terms of the side lengths. So I want to put the opposite length over the hypotenuse. So the opposite length is what? 1, what's the hypotenuse? Square root of 2. So my ratio here is 1 over the square root of 2. And this is something that I'm going to keep revisiting because I really want you to make the connection. When you evaluate a trig function at an angle measure, it doesn't matter if it's degrees or radians. When you input an angle measure, your output, your answer, is the side ratio of triangles, specifically right triangles. All right, and I'm going to be proving that to you again in just a little bit. But here's something else I'm going to ask for you to do. If you create the ratio and you have a radical in the denominator, I'm going to want you to rationalize that. Okay, so that means remove the radical. So how would I do that here? Okay, presumption is absolutely right. Multiply it by the square root of 2 over the square root of 2. We have to multiply by a version of 1. So up top, I would have the square root of 2 over what? 2. Okay, there we go. So what is sine evaluated at 45 degrees? Well, that's the square root of 2 over 2. Okay, and actually that one will be coming up again in just a little bit. All right, let's go ahead and run through the rest of these. Cosine of 45 degrees. Jake, help me out. There you go. The adjacent 1 over the hypotenuse square root of 2. Well, we actually just looked at that one, so there's no need to rationalize again. I already know what the answer is. It's got to be square root of 2 over 2. Okay. Tangent of 45 degrees. Lane, can you help me out with that? Okay, 1 over 1. Opposite 1 over adjacent 1. So this is just 1. Okay. So there we go. There's sine, cosine, and tangent. Okay, the three most popular, I'll say. The most well-known. Now, the other three, remember, they are the reciprocals. So you can either go ahead and use their ratios here. Like for cosecant of 45, I could set the hypotenuse length over the opposite. But if I already know sine of 45 degrees, I could simply take the reciprocal of that value. Can anybody tell me what the answer should be? It's not the exact same thing. Like cosecant of 45 would just be the square root of 2. Remember, it's the reciprocal. So if you go ahead and take the first one here, oh yeah, one sec, Philip. If you take the first one here, the ratio itself, the hypotenuse over the opposite, well, that's just square root of 2 over 1, right? But let's say you just went from the final answer. Let's say I took the reciprocal of that. So 2 over the square root of 2, and I need to what? Need to rationalize. So square root of 2, square root of 2. So this gives me 2 square root of 2 over what? 2. And then those 2's cancel. So I do have square root of 2. So however you want to look at it. Philip? Okay. You want to help me out with the next one? Secant of 45 degrees. It is the square root of 2 again. Perfect. And can anybody tell me cotangent of 45 degrees? Well, what's the reciprocal of 1? 1. Okay. So that's easy, right? Okay. 1, 1, square root of 2. Okay, the lengths I gave. Now, for a 30, 60, 90 triangle, we're going to go ahead and look at these twice. Once for 30 degrees, and then once for 60 degrees. So let's say this is 30 degrees right here. This is 60 degrees. Now, I know the shortest side is going to be x, but how do I find the longer leg using x? Well, now, 2x is the hypotenuse. What do I multiply x by to get the longer leg? Square root of 3. So for a 45, 45, 90, we multiply by the square root of 2. But in the 30, 60, 90, we multiply by the square root of 3 in order to get the longer leg. Hello. Okay. He's not here today.
He's not here?
Okay. All right, so we know the relationship between the sides here. Let's go ahead and use 1. Let's say 1 is my shortest leg because it's across from the smallest angle. So that means across from 60, I'd have square root of 3, and the hypotenuse should be 2 using that relationship if x equals 1. Does anybody want me to go ahead and label these as opposite, adjacent, hypotenuse? Does that help anybody? Okay, Natalia, what's that? Doesn't really matter?
I don't know, y'all. Tell me, what do y'all want?
The definite possibility of a firm maybe?
Just put them down.
Just put them down, okay. All right. So this would be the opposite. This would be the adjacent. And then we have the hypotenuse. Okay. Okay, and let's do the exact same thing, but now we're just going from 30 degrees. So I want sine of 30, opposite over hypotenuse. Okay, Eli, can you help me out with that? 1/2, that's it. Opposite 1 over hypotenuse 2. Nothing to simplify. Perfect. Andrew? Okay, cosine of 30 degrees goes right to it. The adjacent square root of 3 over the hypotenuse 2. Perfect. Perfect, perfect. Fernanda, can you give me tangent of 30 degrees? She says 1 over the square root of 3. Okay, absolutely right. But what do we have to do on this problem? Okay, we want to rationalize it. Okay, so again, I multiply by a version of 1, square root of 3, over square root of 3. So what's my actual answer? Square root of 3 over 3. Perfect. There we go. Now, whether you use the given ratio for cosecant, secant, cotangent, or if you want to use the reciprocal, okay, completely up to you. But how about, Sandra, I want the cosecant of 30 degrees, please. 2 over 1, so it's just 2. Remember, sine and cosecant, cosine and secant, tangent, cotangent, they are all reciprocals. Okay. Laura, can you help me out with secant of 30 degrees? Two over 1. 2 will be a part of it. Okay. So let's start at the beginning. What is secant the reciprocal of?
2 over square root.
Okay. So 2 over the square root of 3. But as before, I need to rationalize this one. So Laura, what would that be?
It'd be 10 square root of 3 over 2.
Perfect. That's exactly right. Okay. And Jordan, why don't you wrap this up for me? I need cotangent of 30 degrees.
Square root of 3.
Okay, square root of 3. Does anybody want me to revisit the previous answer, square root of 3 over 3, and show you how we get this? Anybody want to see that done? Any questions? Anybody having a hard time? Okay. Okay, nobody's out there confused, like, wait a second, secant, Mr. West. Okay, guess not. Okay, next up. Now we're going to do the same thing for 60 degrees. All right, so I'll go ahead and put 60 right here. Here's 30. Now it has the same relationship, x square root of 3, 2x. All right, let's go ahead and say shortest side 1, longer leg, square root of 3, hypotenuse 2. Okay. So I want to evaluate the same trig functions yet again, but now it's going to be at 60 degrees. Okay. So let's take a minute, try this on your own. Okay, take about a minute or so. As you start getting these, you check them with your villain buddy. Kind of lean over and seeing if you're getting the same ratios. Make sure to rationalize. Okay, while you guys are doing that, let's try something. I'm going to go ahead and maybe I don't have to write this out today. Okay, so we're missing Jordan and Michael. Sir? Oh, third period is our accountability for attendance. So that lets us know they want us to wait into the period in case a student is tardy. or is got excused or something like that. So that lets us know we have a 10-minute window when we can put in third period attendance. Okay, so Michael's not here, Jordan's not here. Who are these other three? Well, that's weird. Okay, so I have Eli's right here. Let's see, I put Noe right here. And Jordan Velez was right here. Okay. There we go. Hey, I actually don't have to write that out today. That's nice. All right. Okay, so even if you're not done, hopefully you're the majority of the way done. Let's go ahead and go around the classroom. Let's see who can help me out here. Sine of 60 degrees. Galen, help me out. Perfect. Square root of 3 over 2. Cosine of 60 degrees. Xavier? 1 over 2, 1/2. Absolutely right. Tangent of 60 degrees. Let's go with Clarissa. Square root of 3. All right, 3 for 3. Okay, let's keep that going. Cosecant of 60. How about Cylindric? He says 2 square roots of 3 over 3. Perfect. Secant of 60 degrees. Let's go, Tori. 2. And let's wrap it up with Will. Cotangent 60 degrees.
Square root of 3 over 3.
Square root of 3 over 3. 6 out of 6. Perfect. Now, are there any questions? Would anybody like me to revisit one, elaborate on it, anything? Okay. All right, moving on. Now let's try an example. Using one trig ratio to find others. Let theta be an acute angle such that sine of theta equals 5/6. Okay, so I've got a triangle here. It doesn't matter where I place theta, but once I choose that spot, then we have specific opposite and adjacent sides. So let's say theta is right here. So how can the fact that they're giving me sine of theta equals 5/6 help me find the other trig ratios? And let's just take a step back here. Because they gave me sine, which one do I immediately have and don't have to do any work? Cosecant. Remember, because they're what? They're reciprocal. So if I know that sine of theta is 5/6, well, then I immediately have its reciprocal. Okay. But how do I find the other 4? What do I do?
Well, you have your opposite and hypotenuse.
That's exactly right. These lengths, we know that sine is opposite over the hypotenuse. So this ratio is giving me the side lengths of the triangle. So opposite theta, where I decided to put him, I'm going to place the 5. The hypotenuse is 6. Well, that's all well and good, but I'm missing a side, the adjacent. Pythagorean theorem. What is that? There you go. A squared plus b squared is equal to c squared. Okay. So let's just say this missing side right here is a. So a squared plus b squared, so 5 squared is 25, equals c squared. What would that be? 36. So a squared is equal to 11. And what's a? Square root of 11. Now, this is one of those times where we'd think we'd go ahead and put the plus minus in front. But why do I not need to do that here? Why am I going to leave it as is? There you go, because we're talking about a side length, right? We don't think about, distances being negative. Now, that's not going to always be the case. We will eventually get to figures that are going to look like they have a negative side length. And we're not saying that's a negative distance. The negative just helps me determine what quadrant this triangle is going to be in. So we will get there. Okay, so square root of 11. All right. Well, let's see if we can get some folks up here to help me out. I need somebody to help me with cosine and its reciprocal secant. Natalia, you want to do it? Okay. All right. And then after that, we'll see if we can't get somebody to come on up and show us tangent and cotangent. Okay, so cosine was adjacent over hypotenuse. So she said square root 11 over 6. That's perfect. Now secant would be the reciprocal. There we go. She immediately gets to rationalizing. 6 square root of 11 over 11. That is perfect. Any questions? Okay. All right. Who wants to help me out with 4C and 4F? The last pair of reciprocals. So many hands. I don't know how many to choose. Oh, Jordan. All right. Thank you, Jordan. Okay, so tangent is the opposite over adjacent. Okay, goes right to rationalizing. Perfect. And go ahead and do the reciprocal as well. Yes, sir. Okay, what do you guys think? That's perfect. That is exactly right. Okay, good, 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 good. All right, now I want to go ahead and take a moment to talk about the calculator, because moving into trigonometry, the calculator is going to be very, very useful and essential in a couple of times for us. So the first thing we always want to make sure, let me get rid of this right here, from your home screen, you always want to make sure you know what mode your calculator is in. Right now, we want to be in degrees. Okay, so from your home screen, I'm going to go to 5 settings. Okay. Then I'm going to go to document settings, and it's going to be this second tab right here. You see mine is already in degrees. Now, if yours happens to say radians, you'll just click it, go ahead and choose degree. But here's the thing, don't click OK, click make default. These inspires are kind of peculiar. If you were to change it from radians to degrees and you just clicked OK, it'll work for one problem, one computation, and then it'll automatically revert back to radians. So that's why we want to go ahead and click make default. Okay, and yes, I do want that. All right. So now if I go to A, let's just go ahead and type it in. The first thing we want right here is the cosine of 30 degrees. Well, if you look over here on the left of your calculator, right next to number 7, right below the blue control button, there is a button that says trig. If you click it, you got all 6 of your trig functions with their inverses. So what we want was, what was it, cosine of what? 30 degrees. So I know mine's in degrees. So I have cosine. I'm going to type in the 30. And I'm going to go ahead and push enter. And it's going to give me a value. But I want you to understand what this value represents. It's not just some random number. Okay. Remember what I was saying earlier? What are we inputting into the function? We're putting in an angle measure. Now here we're putting in degrees, right? So that's my input. What's the answer that I'm getting? It represents the ratio of 2 sides of a right triangle. In fact, let's kind of look at this one in a little bit of detail. I'm going to create a right triangle. We got this one here to be 0.8, I think it was 866. Okay. So let's say we have 30 degrees, we have 60 degrees. Okay. So across from 30 is 1, square root of 3, and then we have 2, right? So cosine of 30, we just looked at this a little while ago, would be the opposite, or excuse me, the adjacent, sorry, square root of 3 over the hypotenuse 2, right? So if I input an angle measure, the output is the ratio of the sides of a right triangle. Well, let's actually see what square root of 3 divided by 2 looks like. Square root of 3 divided by 2. There you go. Okay, so that's what these trig functions are doing. You evaluate them at an angle measure, your answer is going to be the ratio of sides. Now, in this case, for cosine, it was the adjacent side over the opposite side. Okay, but just kind of be thinking about this as we run through each of these. In fact, can anybody help me out with sine of 45 degrees? There you go. I think it's like 70, 71, something like that. So we'll say 0.707. Now, this is one of the ones previously that we looked at because it's got an angle part of a special right triangle. So if you go all the way back, I believe it's to the second page, okay, or maybe the first, okay, here's sine of 45. Here's the ratio that we got. So what do you want to bet that square root of 2 divided by 2 will have that exact decimal value? Okay. So is everybody understanding what evaluating a trig function provides you? It's giving it to you as a decimal, but it's the side lengths of a triangle, a right triangle specifically. Okay, let's see if somebody can help me out with the rest of these. Tangent of 90. Undefined. Okay, this one we're going to run into a problem. And I will go ahead and talk about this in a lot more detail later, especially when we get to the unit circle. But let's think about 90 degrees. Where would he be? Okay, what's that? Well, no, you're right about the ratio, but I'm talking about, you remember how we were graphing the terminal sides yesterday? Where would 90 degrees be? If this is my x, this is my y. We start rotating from standard position. We rotate counterclockwise. Now, is it in a quadrant? It's not in a quadrant, so it's on a what? It's on the y-axis. Here is 90 degrees right there. There's the terminal side. Okay, so what you're going to notice as we start going through is that you're not going to be able to create a triangle based on what you have. Here you would have a triangle where your side lengths would be 0. Okay, so that's why we're getting undefined. Like I said, I'll go into that in a little more detail later on. Okay, but just to kind of give you an idea as to why that is. In fact, does anybody remember what we call it if the terminal side stops on an axis? Starting with a Q. Larger word. Quad. Quad what? Can't remember the rest of it. Quad. Okay, quadrantal. There we go. Remember, we call that a quadrantal if the terminal side stops on an axis. All right, so let's see, who haven't I talked to today? Emma's back now. Okay, Emma, what would you tell me for the sine of 15 degrees? Oh, hasn't done it yet? Okay, Noe? A sine of 15 degrees. 0.259. There we go. Sine of 15 degrees. That means if I'm looking at a triangle that has a 15-degree angle, specifically a right triangle, if I take the ratio of the opposite to the hypotenuse there, those lengths should be giving me a 0.259. Okay. Let's see, who else have I not talked to today? Kaushal. Okay. Kaushal, what would you say for cosecant to 45 degrees? 1.414. Perfect. And we'll finish up cotangent to 45 degrees. Caleb. 1. There you go. That is exactly right. Okay, so any questions on that? Anybody having a hard time? Okay. Well, I think all we got is a couple of application problems, and we are done today. All right. Let's take a look. A right triangle with a hypotenuse of 8 includes a 36-degree angle. Find the lengths of the other two sides and the measures of the other two angles. Well, really, you only got to find the measure of the other angle because we know it's a right triangle. Okay. So let me go ahead and draw a right triangle. And it doesn't matter how you draw it as long as it's right. Okay. Not, you mean right, not in terms of correct, but you want it to be correct as well. All right. Now, let's go ahead and name the triangle ABC. So you remember from geometry, we always name the vertices using a capital letter. How do we name the side lengths? Remember, those were lowercase, so this would be side B, side C, side A. Well, we're told that the hypotenuse is 8, all right, and we have a 36-degree angle. So let's put 36 degree here, okay? And it really doesn't matter where you place that angle, how you draw your right triangle, as long as all the information is correct, all right? So let's start with angle B, because that's going to be the easiest thing to find. Anybody tell me what the measure of angle B is? It is 54 degrees. Okay. There we go. Now, there's a couple of ways you could have done that. What's the interior sum for all the angles of a triangle? 180. So you could have taken 180 minus 90 minus 36. Now, personally, if I know I'm dealing with a 90 right triangle, I already know that that one angle is half of what I need. So what do we call it when two angles will add to 90? What was that word in geometry? Complementary. There we go. If they added to 180, they were supplementary. Good. Good, good. Okay, now what I need to do is go ahead and find these other two side lengths. And I'm going to use a trig function to help me do that. But is there just going to be one way to find these? Let's say B. Let's say I want length B. Okay. What are some different trig functions that we could use based on the information we have? Okay. We could use sine. Okay. Now, what angle would I have to use if I want sine? Would it have to be 54 or 36? There you go. If I want to go ahead and find side B and I want to use sine, then I have to use 54, because remember, we need the opposite over the hypotenuse. Okay, so I can set up an equation like that. I could say the sine of 54 degrees equals the opposite B over the hypotenuse 8. Okay. Now, is that the only one that'll work? Now, if sine will work, then guaranteed what else is going to work? Starts with an R. It's reciprocal. What's the reciprocal of sine? Cosecant will work as well. Okay, but let's just say we stuck with this one. How would I solve for B? Yeah, just multiply through by 8. By 8. By 8, those cancel. So let's see here. I'm going to say 8 times the sine, 54 degrees. Okay, so what should I be getting when I push enter? Okay, getting about 6.5. Is that what you folks are getting? Okay, so let's say about 6.5. Okay. Now, at this point, do I actually need another trig expression to find C? No, because I now have two sides of a right triangle. I could do what? Could use Pythagorean theorem. I want to point something out, though, and we're going to be seeing this as we go through all these lessons. If I were trying to find C, I would not use 6.5. What's going to happen if you round in the middle of solving a problem? Yeah, it'll definitely affect your answer, right? So if you were going to go ahead and use the Pythagorean theorem, I would strongly encourage you to use the exact decimal value that the calculator provided. It's going to give you a much more approximate answer. Okay, but I'm just going to go ahead and use a trig function because that's what we're talking about today. Who's someone I haven't talked to today? Connor, I haven't talked to you today. Give me a trig equation that I could use to solve for C. And it doesn't matter if I still stick with 54 or I go with 36. Okay, so you want to do sine again with 36 degrees? Okay. So that ratio would be now the opposite for 36 would be C over the hypotenuse 8. Okay. And then now, just like before, we can multiply through. And remember, this is not the only way we could do this. I mean, there's a little bit of leeway here. I mean, it's not completely open, but you have options. So 8 times the sine, 36. What do I get? Okay, I heard 4.7. Perfect. So let's say about 4.7 units. And a lot of times in trigonometry, you're just going to be told solve this triangle. Well, if you're told to solve a triangle, that means find every missing angle, every missing side length. Okay, it's just kind of a condensed way of saying that. Anybody having a hard time? Everybody good? Okay. All right, well, we got one additional problem here. It's not often that we can get an entire lesson done in one day, but we feel good, right? There we go. Okay, there we go. All right, well, let me read the problem. Let's see if we can't get somebody up here to kind of finish this out for me. From a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, the angle of elevation to the top of the building is 65 degrees. Find the height of the building. So I'm looking for the height x, or whatever variable you want to use. Hint, find a ratio that will relate an angle to the sides, usually the opposite and adjacent. Okay, so somebody want to help me out with this? What two trig functions is it referring to? Tangent and cotangent. There we go. So we already have the trig function. I just need somebody to come on up and show me the equation so we can find out how tall the building is. Okay. Who was the last person to come up? Was it Natalia? Or no? Someone came up after her. Jordan, you came up after her, right? Okay. Jordan, who would you like to see come up and work this problem?
Wayne, how about you?
All right. The expression of gratitude on Lane's face says it all. Okay. Okay, so walk us through this, Lane. Okay, so he's using tangent.
65
Okay.
go to the opposite of x over here, 340,
Uh-huh.
and then multiply 340.
And then you just multiply through by the 340. Okay, so, oh, did you already get it?
Yeah.
Good, good, good. So, 729.132, we're talking about feet. Okay. Would you folks agree? That's it. That's all there is to it. Okay. Any questions? How we doing? Okay. We are done.